All right, everybody, ready to dive in. Today, we're tackling a topic that might sound, well, a little back to school.
Geometry.
Exactly. But trust me, this deep dive is all about uncovering the cool stuff, the aha moments hiding within lines and angles. We've got some geometry textbook excerpts to guide us. And let me tell you, they're packed with surprises.
It always amazes me how these basic elements of geometry, these lines, angles, rays, they form the foundation of so much around us.
They're like the secret code behind design itself. I mean, think about it. Everything from a simple chair to like a massive skyscraper, it all starts with these building blocks.
Absolutely.
So to kick things off, the textbook starts with the basics. Lines, line segments, those rays we talked about. And anytime two lines decide to meet, boom, you got yourself an angle.
And that angle can tell us so much. Is it a narrow angle? Like picture a tiny sliver of pie.
Okay, got it.
Or is it wide, like a giant slice of, I don't know, watermelon? That's where those terms come in: acute, obtuse, right angles, all about the degrees.
And the textbook uses this really cool example, actually. Opening a book.
Oh, I like that one.
Right. You open the cover, and bam, you could practically see those angles changing right before your eyes.
Such a simple way to visualize it, though, right?
Totally. And as you keep flipping through those textbook pages, it's like you're uncovering these like hidden relationships between all those angles.
It's all connected.
Which brings us to, well, the textbook calls them special angle pairs.
Ah, yes.
Complementary and supplementary angles. What makes these pairs so interesting from, your perspective?
Well, they're like puzzle pieces, you see.
Yeah.
If you know one angle in the pair, boom, you instantly know the other one.
No way.
Yeah. Complementary angles, they always add up to 90 degrees. Think like the corner of a perfect square.
Okay, so if one angle is, say, 30 degrees,
And you automatically know the other one's got to be 60 degrees.
it's like a mathematical code.
Exactly. You crack the code, you unlock the missing information. And the best part, this principle, it's not just stuck in textbooks. Think real world, like carpentry. A carpenter, they rely on this stuff all the time to make sure everything lines up perfectly.
Oh, that makes sense.
Can you imagine trying to build a house, a whole house, with walls that aren't at perfect 90-degree angles?
Disaster waiting to happen.
Total chaos. And that's just one example. Understanding these angles, it's crucial in so many fields. Engineering, architecture, even art relies on these principles.
So it's bigger than just, got to memorize these angle facts for a test. It's actually used everywhere.
Absolutely.
Okay, so we've got complementary, supplementary. Now, the textbook throws another term at us, adjacent angles.
Right, and this one's pretty intuitive.
Are those just like angles that are next door neighbors? Like they share a fence, or in this case, share a side and a vertex?
Exactly. Think of it like slices in a pie chart. Each slice is an adjacent angle to its neighbors. They sit right next to each other.
Gotcha. So, building on that idea, if those adjacent angles happen to be supplementary, meaning they add up to that magic 180 degrees.
Then, my friend, you've got yourself what we call a linear pair.
Ah, so it's like a straight line that got split into two angles.
You got it. And they're always, always supplementary, which, again, circles back to that puzzle piece idea. Knowing one angle, boom, you got the other.
I'm starting to see the connections here. So we've got angles next door to each other, angles completing each other. What else is there?
Well, then we come to what I like to call the X marks the spot relationship. Vertically opposite angles.
And they're always equal, right? Like, no matter what.
You know it. Vertically opposite angles, always congruent. It's like a fundamental law of geometry. And speaking of cool geometry facts, the textbook, it actually tells you to try this next one at home.
Ooh, I love those.
Right. So, grab some paper, a pencil, maybe a ruler if you're feeling fancy. Draw yourself two lines that intersect.
Okay, easy enough. Got my intersecting lines.
Now, focus on one pair of those vertically opposite angles. Trace one of them.
All right, got my tracing.
And now, for the grand reveal, rotate that paper.
Whoa! It's like magic. My traced angle, it lines up perfectly with the other opposite angle.
See? It's geometry in action. No matter how those lines intersect, those opposite angles, they're always going to be congruent. Pretty neat, huh?
Totally. It's like they're like mirror images of each other or something. Okay, so we've tackled vertically opposite angles. What's next in our geometry adventure?
Well, buckle up because things are about to get a little more interesting. We're moving on to parallel lines.
Okay, like train tracks.
Exactly. Those train tracks, they're never going to meet, right? They stay perfectly parallel. But now, imagine another line comes along and cuts across those parallel lines.
Like a road intersecting those train tracks.
You got it. That, my friend, is what we call a transversal. And let me tell you, that one transversal, it creates a whole new set of angles and relationships to explore.
It's like opening a treasure chest of geometry secrets.
I like the way you think. So first up, we have corresponding angles.
Corresponding. Okay, got to write this one down.
Basically, picture this. You've got your parallel lines, right? And your transversal cutting through them. Corresponding angles, they occupy the same relative position around each of those intersection points.
Okay. So, like, if one angle is in the top left corner of one intersection.
Then its corresponding angle would be in the top left corner of the other intersection, too.
Okay. Like matching corners.
Exactly. They're like looking at the same thing, but from different spots along those parallel lines.
Okay, starting to click now.
And get this corresponding angles. Always congruent. Always.
So if I know one corresponding angle, I automatically know the other.
You got it. Now ready for another one? We've also got alternate interior angles.
Alternate interior. Okay, those words sound a little intimidating.
Don't worry, they're not so bad once you get to know them. So picture those parallel lines again with the transversal slicing through. Alternate interior angles are like the opposite of corresponding angles. They're on opposite sides of that transversal. But here's the catch. They're tucked inside those parallel lines. And you know what? They're always congruent too.
No way. Another set of equal angles. Geometry is full of surprises.
It's all about those hidden connections. And here's a little trick to remember them. Visualize the letter Z.
Z?
Yeah, the angles forming the top and bottom of the Z and the diagonal part being that transversal. That's your alternate interior angles.
Wow, that's pretty clever. I'm definitely going to remember that.
See, geometry can be fun. Okay, one more type of angle to cover. Interior angles on the same side of the transversal.
All right, let me guess. They're on the same side of the transversal, like inside those parallel lines.
You're on a roll today. Now, here's where things get a bit different. Unlike corresponding and alternate angles, these guys, they're not congruent.
Wait, really?
Yep. Instead of being equal, they always, and I mean always, add up to 180 degrees. Remember those supplementary angles we talked about?
Yeah, like two puzzle pieces making a straight line.
Exactly. So even though these angles are different, they still have this special relationship, this connection.
No, that's pretty cool. It's like, even when they're not equal, they still have to follow a rule.
And guess what? We can actually use this property, this always adding up to 180 degrees thing, to figure out if two lines are parallel. If those angles add up perfectly, bam, you know those lines are running parallel to each other.
No way. So it's like a geometry detective tool. We can use angles to solve mysteries about lines.
Exactly. It's all connected.
So we've gone from lines on a page to like the blueprints of actual buildings. I mean, it's amazing how these angle rules, they're not just some abstract concept.
Oh, absolutely. We're talking real-world applications here. It's like, think about those massive skyscrapers, the ones touching the clouds.
They don't just magically float up there.
Not at all. Those buildings exist because architects, engineers, they've mastered these geometric principles we're diving into.
It's like those buildings are whispering geometry secrets if you know how to listen.
Exactly. And speaking of tools that speak geometry, the textbook mentions the T-square. Classic drafting tool.
Oh, yeah, the T-square. Isn't that like the L-shaped one?
That's the one. And it's basically a physical representation of those parallel lines, those transversals, everything we've been talking about. Helps ensure those perfect 90-degree angles, crucial for any structure to, well, not fall down.
It's like a little piece of geometry magic right in a builder's tool pit.
And it's not just the T-square. Think about a carpenter using a level. You know that thing with the little bubble?
Yeah, got to make sure things are straight. But wait, is that geometry too?
Absolutely. They're using the power of those same geometric principles, making sure a surface is perfectly horizontal, perfectly aligned with gravity itself. That's how you build things that last.
Mind blown. It's like these builders, they're speaking the language of angles and lines without even realizing it.
Precisely. It's all around us. Once you start noticing it, you'll see those parallel lines, those transversals, even in the most everyday objects.
We really did unlock a secret code today, didn't we? Who knew lines and angles could be this cool?
It's all about perspective, right?
Totally. And on that note, we'll leave you all with a newfound appreciation for those shapes hidden in plain sight. Turns out, math isn't just about equations on a chalkboard.
It's the language of design, of architecture, of the world around us.
So next time you're out and about, take a second to look around. Can you spot those parallel lines, maybe a transversal cutting through? What about those angles holding up buildings, bridges, everything?
Keep asking those questions. Keep exploring, because that's what this deep dive's all about.
And who knows? Maybe you'll unlock a few geometry secrets of your own. Until next time, keep those aha moments coming.